Get ready because the shipping industry is ripe for disruption. You're listening to Autonomous Ships Headquarters Podcast with your host, JP.
Hello, everybody. Welcome to the podcast. Today's guest has been working on marine autonomy for almost 10 years. He holds a PhD in marine autonomy, and today he teaches at MIT as a visiting instructor. Besides all of that, he's also founder and CEO of blkSAIL, that is blkSAIL. With his deep technical understanding of cutting-edge robotics and being located in Boston, which is without doubt one of the powerhouses for maritime robotics, there is no better person to talk about maritime autonomy. So without further ado, please meet Mohamed Saad Ibn Seddik. Hey, Mohamed.
Thanks,
Welcome to the show, man.
Appreciate it. How are you doing?
Great. All good, all good. Ready to fire this one up. So as a start, why don't we dive and can you explain me and the audience what does it mean for a ship to be autonomous and how does it actually work? If you could give it a good technical overview and an explanation.
Of course. So autonomy for ships is not very different for what people are thinking more familiar with in cars. In a car today, you can jump in and then, on your GPS input a destination, and then you can start driving manually. But you can usually, put an automatic speed, so it maintains that speed. Some cars have automatic braking, automatic lane assist, and all these kind of features. And then in the future, some Tesla, for example, and Cruise and some other companies have capabilities that goes a bit further than that, where not only you are getting speed and maintaining your lane, but you can also change lanes, make turns and whatnot. For ships, it's the same. Ships for years had autopilots that could maintain their course. They have engine rooms that are really well instrumented, and they have even DP systems that can allow them to stay in a certain position at sometimes centimeter accuracy. For the autonomy and what we're adding for the maritime industry is this capability of perceiving the environment, understanding the environment, and then from there taking a decision to sail towards one point or another. Many systems already exist where from a DP system you can set up a set of waypoints that the vessel will follow, but that's not what really the autonomy is. The autonomy, from my view, is where the vessel understands its environment and is capable of interacting with it. So let's say there is a buoy that needs to be avoided that was not on the chart, for example, when we start sailing. It should be able to avoid it. Let's say there is a sailboat or another vessel. It should be able to understand the rules of the road, the intention of the other vessel, and then from there be able to sail around it while following the rules of the road, the call regs. And the way that's done, it's by taking all of the information from the sensors that are already existing on the vessels, on these ships, and potentially for closed environments or some areas that are busier than usual, or ports or inland canals, you might need some additional sensors that are not already on board the vessel to augment the perception and therefore be able to sail safely and more efficiently.
Mm-hmm. When I was researching autonomy in automotive industry, they usually divide this software stack in perception and control. Do you have same approach in maritime? And if so, where in this stack is artificial intelligence used, and where are more traditional control loops used?
I would say actually it's for at least the maritime industry, there's a little bit more than just that, than just these two. There's also the routing and the voyage planning. That's really important for these vessels because in the open ocean, let's say, we do not have channels that you can just go in and then follow. You don't have roads, you don't have stoplights, you don't have none of that. And therefore, it's really important that as you're sailing, the vessel should be able to dynamically either change its route if there is, let's say, a big storm or something that was not predicted in initial planning, and be able to change that. So for that, these are areas that normal planning and control can be applied. AI, like you mentioned, can actually be applied for both from the control side and the perception side. From the control side, has been a lot of advances in both. We can call them traditional AI, where it's more of an expert system that a human or an expert can input all of the information to be able to say, okay, this is how, and they can describe it really in details, how a target looks like in a radar, or how a vessel looks like in a camera, and then have the program that they will detect those objects in these inputs, or use what's new now, which is relatively new, which is the second wave of AI, which is more based on deep learning, where on machine learning, where the system can learn from existing images that are labeled, for example, by humans and radar images, to be able to say, okay, this is a boat, or this is a ship, or this is a tanker. And if you see this again in the future, you should be able to learn that this is kind of the same thing. And therefore, over time, you can have better results than initially that can be programmed. So let's say tomorrow there's a trimaran that no one ever saw or described before in the program. Technically, the machine learning program should be able to detect that and understand it. So that's one way of doing it. The other option as well is, and this is still in research and development stage, where we want the system to not only learn by itself, but be able to describe what it learned. And this is where there's a shortcoming, for example, for deep learning right now, is that most of the people consider these as black boxes. You do have some results, but you don't know really if there is going to be any results that are obvious, but that it will be ignored. And you can see that in autonomous driving, for example, a stop sign by adding just tape around it can be detected as 90 miles per hour, for example, sign. And you can imagine if a car is driving and sees a stop sign, but because someone whether on purpose or not, put some tape around it, understand the car understands 90 and then goes to the speed limit of 90 where it's supposed to stop, that's going to be a huge deal. So this is where the third wave of AI, explainable AI, if we can call it, is going to be the next interest. And from the control side, that's really what blkSAIL is focused on. We want to be able to learn the dynamics of the vessels that are around us. Usually that's done through the perception systems, and then from there be able to predict where the systems are, what the intentions of these other targets that we see, and understand what should be done from the ownership perspective, and then from there should take a decision and explain it to the humans. Because I think and I strongly believe that for humans and captains to be able to trust their life, their cargo, their ship with an AI, the AI should be able to explain what it's doing and build this kind of trust. So we strongly believe at blkSAIL that the only way of having some kind of autonomy and AI on board a ship is to build this trust between the captains and the seafarers and the AI that will do this. And this is where our approach of decision support first, where the AI is giving recommendations to the captain and the officers on the bridge, so they can understand better the results and what the AI is recommending before trusting it and engaging it for long term. And this is not doesn't just apply to the seafarers and the captains. It applies as well to the governments and the regulators about authorizing AI, what can be done, and also to the insurance industry, because at the end of the day, if the insurance says no, you cannot have an AI captain, I don't think there is any market for that.
Well, how important is the repeatability in this? In a sense that should the ship each time in the same situation react in the same manner, and you would like to, see all the environment and all the inputs to this system and understand why it made certain decisions?
So for blkSAIL, we do have our navigation simulator, which is not a good rendering simulator. It's not like a game engine that would render stuff visually nice, but it can render physics and mimic physics as much as possible. And with that, for example, we can run thousands of ships, thousands of encounter situations that will allow us to actually, and allowed us before, to understand where there's a shortcoming for the AI. And we noticed, for example, sometimes the AI, for example, would prefer to do some, for example, in the Corex situation, if there's a head-on, a vessel is coming straight in front of you, you are supposed to turn starboard towards the right, and the other vessel is also supposed to turn starboard towards its right to pass it on the port side, the left side of each ship. We noticed that, for example, our AI, if it sees that the other vessel is not following the Corex, because this is also something that we added in our system, because we suppose that not all vessels are aware of the Corex, and then you can think as let's say an AI vessel or an AI operated vessel is clearly an AI operated vessel. Maybe some human would want to hijack it, and we've seen why the motivation behind that is that we've seen this with cars, that if an autonomous car is driving, there will be some humans trying to make a mistake. And that's the kind of stuff that we start testing with our AI as well. And here, what we noticed is that the AI, when it sees that the other vessel is not following the Corex, and it sees that it will not have time by itself to just turn to its port side, it will go a little bit too close to the other vessel. It will actually decide to turn to not going to turn to the starboard side. It will turn to the port side to pass the other vessel at a safe distance, which is technically a violation of the Corex rules. However, it's not a violation of the Corex, because the number one rule of the Corex is not get anywhere close to an incident. And that's really important for our systems.
That's super important to have this hierarchy embedded in the code, right?
Exactly. Yes. And you can see that the AI is capable of deciding, okay, right now I do not believe that there is a safe way of just following the Corex, because we're going to get too close, and clearly the other vessel is not following the Corex. So what we want to do is go the other way, but always be on the safe side. But if the other vessels following Corex, then the own ship will follow the Corex, because it sees that by predicting over what we do is usually a window of at least 12 minutes in the future, all the possible scenarios, and then if all the possible scenarios are good, we're gonna take any of them. If there is a scenario that's it's risky, we're gonna try to eliminate that from our decision space.
The big part of this decision-making process is obviously the maneuverability capabilities of a vessel that you're trying to avoid. So how is that embedded in your solution? Because avoiding a fishing boat with certain maneuverabilities is different than having a full head-on with a tanker. So how does that work?
Excellent question. This is actually something that we also implement in our system, which is learning the dynamics of our own ship, and then the dynamics of the other ships around us. So our own ship, that's where we basically over time we build almost a perfect digital twin of our vessel. It's always continuously learning how the dynamics of the vessels are under this kind of wind, under this kind of load, under this kind of current. What can at this RPMs, for example, what's the predicted speed? What's if we change the rudder at this tiny bit, what's the speed in that side? And with all of these, basically what you get as a result is this kind of really good twin of your vessel. So what we can do with that is predict over time and in future what are all the different options that are possible for our vessel, and therefore have really good precision for our vessel. Like you said, for example, if in the flip side, let's say we're just in an area, and then there's another vessel that we see. This at that time we will have, let's say, a little bit less of an accurate model because we're not on board, so we don't observe the vessel in real time. So we observe it through the radar, through the AIS, potentially through cameras and whatnot. And from there, we start seeing we start learning for that period of time, that since we start seeing it till the time we're taking a decision, how it behaved. And therefore, from that, we start predicting the dynamics of the vessel in the future. And the difference here between I think our approach and what's been done before is that we're not only taking, let's say, just the speed on the course and then we multiply by the seconds to know where we're going to be. We kind of do a little bit more dynamics approach where integrating potentially what's the acceleration of that vessel has been over time, what's the turn rate and all these kind of stuff. And then we don't build just a point where the vessel is going to be, or a line where it's going to be over time. We build some you can imagine as a cone that goes through space and time to say, okay, here's where.
Sounds awesome.
Yeah, it's. I think the challenge here is really, I think, to visualize it, and this is what we've been working on almost the last year or so, where how can you display all of this information to the captain? Because what you also don't want is overload the captain. They or the people in the bridge. They already have thousands, or not thousands, but tens of screens around them. Each one of them has an alarm. Each one have different information. So how can we, from a user experience perspective, bring value to these people so they can make the best decision possible? And that's, I think, one of the most important pieces that we focused on, and we believe will make a difference in this space.
And if I got correctly, you do, so when you encounter a vessel, you do record and observe its dynamics. Is this, for example, linked to a registration number for that vessel? So if, for example, if you've seen a vessel in Singapore and you're recording it again in Rotterdam, that you kind of already have data on it?
Correct. Yes. So most the vessels that do have AIS, we kind of link the AIS together, and that's usually how we do it. So far, we don't implement any other way of linking two points together if they're not continuous, and that's because of the fact that we have not yet invested heavily in the perception side. So the radar usually they're not they're 2D radars, so you cannot just from a radar signature understand which vessel it is, and just it's a huge VLCC or something like this, and we don't kind of work on the cameras yet. So if the AIS, we have an AIS system, we then understand that this is something that we've seen. It's recorded in the database. These are the last inputs of the results of our dynamic observation, and this is how we predict it's going to be. Of course, if it changes, if we see that's going much faster and has more nimble, that means that probably it's loaded differently. Maybe it's there's nothing on board, and therefore we update that over time.
Awesome. Speaking of these technologies, especially what are, in your opinion, key missing pieces for wider commercial adoption of these technologies?
Honestly, I think it's going to come down to trust between the humans and the AI over what can be done and what can be achieved. I think that's like the number one thing that the number one challenge that we need to overcome. And two, the financial perspective, because at the end of the day, the maritime industry is like, really has really thin margins. So there's a lot of negotiation that goes in when someone wants to charter a vessel on all these kind of information. So it's really important for anyone to make a strong business case about adding this AI. From our perspective and how we work with our clients, is that we first I would say also it depends really on the client, because we have clients that are shipbuilders, we have clients that are ship operators, we have insurance as clients, and all of these guys have different kind of interests. So for an insurance perspective, what they want to know is there a big difference between what the AI is recommending and what the human is doing. From a ship operations perspective, they want to make sure that that vessel is operating to their standards at most time. That if there is new mates on board, are they trained enough for what they're doing? And then from a shipbuilding perspective, what are the new technologies that they want to put in to be able to service the autonomy and the future of the industry and not be left out. So because of all of these kind of separate separate interests, I think
from
for
different
us
stakeholders, right?
Yeah. So for us, it's the best approach is make sure that everyone involved has trust in this system, and no one sees it as taking their job out. So we're not taking the job of the underwriters in the insurance by providing this. We're not taking the jobs of the captains. We're not taking the jobs of anyone else. We're here really as a support. Plus, over the long term, and if we're being honest, you can see that already happening in Japan. There's a huge shortage of seafarers, and it's less and less attractive to young people to be captains and seafarers, because there's so many other things that they can do. And one of the things that I think really struck me with our first client was that the captain that was testing the system with, I was like, why are you he was way too excited about an autonomy, because we're doing an autonomous ferry. I'm like, why are you so excited about this? And his answer was that, well, that means that every night I will be able to go and sleep home and then kiss my kids goodnight every day. And he was not able to do this before, when he was a tanker captain. When he's a ferry captain, sometimes he needs to work during the night, so he cannot do that. But with this kind of technology, he will be able to do this and be around his family. I think that's gonna make it more viable for the industry, without even touching on the new business cases that I think will be enabled by autonomy at scale.
Yeah, completely agree. And let's zoom a bit more on your actual solution. Is there a specific type of ships or boats that blkSAIL's solution is aimed at? And if you could tell us how does it consist? What does it consist of, in terms of hardware and software?
Sure. So blkSAIL's solution, first and foremost, is to assist captains in their operations. So the way we do this is to provide them with real-time decision support. And this is the same kind of engine that does the autonomy. It's just that it doesn't take control of the ship. It just displays that information on an iPad. So when we work with the ship owners about around this, we provide them with a box that looks like a Pelican case that has an AI edge computer on board that can process the data. It takes all of the inputs from the existing sensors, so there's no capex involved from a ship owner perspective, and then does the computations and then shows them on the iPad. It looks like an ECDIS chart. So you see where the vessel is, you see where all the other ships are, and then you see basically the recommendations. Like, here's what's your speed, here's what we think your speed should be, here's what we think your course should be, and here's why. So that's one of the things that we do. The other thing is if we're doing autonomy, then there is a little bit more hardware involved, but this hardware is required to connect to the autopilots on board. So when we are for these autonomous, I usually like to call them semi-autonomous. Because we are not capable of, for example, yet operating in ports and busy areas where for example there can be a sailboat or something like this. Because usually especially new sailboats, they're carbon fiber or fiberglass, and you cannot see them in the radar, and we don't deploy any cameras yet. So that kind of doesn't work yet. So this is why we call it semi-autonomous. So in that situation. What we provide is this pelican case, this iPad, so they can see, and then whatever interface that is required to connect to their ship. So our main targets right now are ocean-going ships. So we prefer that they go in the open ocean, outside in international waters. It's easier for us as we start. So there is traffic that we can see and perceive correctly. That there's a little bit less risk of having a yacht that's not visible in radar or something, or or a kayaker that would not have IIS, for example. And we have also clients in inland, for example. And this is one of the funny things. As we were sailing inland, someone jumped in the water trying to board the inland vessel. So it's good that the captain had cameras, so he was kind of remotely operating it, so he had cameras, so he saw that, and then tried to dock the vessel before this person boards it. But that's the kind of stuff that I think is yet to be worked on, and also from a perspective of how do we call it, regulations, to have what really can be done. Because if we're just going for these kind of systems, someone that sees an inland vessel that with no one on board was okay, well, this is drifting, so I can go and hijack it or call it mine. But
see what's going on board.
Yeah, so I think that was the intention. I think, and the good thing here is that the captain noticed the guy on the side of the canal, taking his clothes off to jump in the water. So he knew that something was weird is about to happen. So I think that's the kind of stuff that honestly, I would say having a full autonomy is a little bit far out, especially in these kind of situations inland and whatnot, because there is still systems that needs to be developed to guarantee a safe operation. So we really, that's our motivation why we're focused on going for the open ocean. So this kind of situations happen less.
Mm-hmm. Yeah, but all the good lessons learned on the open oceans can in some way be learned to, for example, inland, with additional sensors, with putting some more additional structure around the environment.
Absolutely, yes.
Right.
Yeah, and over the long term, yes, that's our plan. Is that we don't want to be just in the open ocean, and the way we see blkSAIL is that we want it to be as ubiquitous as GPS or radio on board ships, where wherever you are, you kind of need to have it. But it's good to start somewhere where we kind of know that we will be operating better than anyone else, and get more data than anyone else. And this is, I think, one of the advantages of our early clients is that, and especially with everything AI, is that the first people that adopt it are the people that will always be gaining, because it's just, think about it as continuous learning. So if you start learning something today, there's basically no one who's gonna catch you on learning what you're learning, simply because you don't stop learning. And this is how our system works, is that our system continuously learns, keeps learning over time. And the only way of someone your competition beating you in this is that if you decide to stop learning, and therefore for our case, for example, disconnect the system, then yes, someone will catch you. But early adopters have always this advantage in AI. And I think it's really important to highlight
advantage of first movers, especially when it's about data quantity and quality. And I know you have a big emphasis on safety and redundancy. And can you explain us how your system doesn't have a single point of failure?
Of course. So from a perspective of our system, so we have both software and hardware redundancy. So the computers that run the AI, there's two of them. In case one fails, there's another one that can kick in and overtake. But even before the computer fails, we're working also on the software side. So every system is monitored at all time. We basically and you can think about it as it's a mix between aviation, what's done in aviation, and what's done in the cloud, where in aviation you have all of these systems that are always redundant, that have multiple ways of getting data, and in the cloud where every software is monitored at all time, you can know the status of all the different components. And this is how we decided to take our system. So it's not a monolith. So it's not just one program that runs. If it crashes, everything shuts down. It's we try to split it as small as possible. So you have one process, for example, that would read the data from the VDR, one process that would read the data from the radar, one process would read the data from all of these inputs. And if one of them, for example, fails, we know which one failed. So let's say that the GPS fails, and then we restart the program of the GPS process and it doesn't work. Then we know that, okay, we don't know where we are anymore. So that's one of the alarms that can be really well described to the captain, that this is critical. We don't know where we are anymore. And of course, both computers will check that and try to work together to find a solution. And we try to again involve the humans as I would say as late as possible from a perspective of the software. But as late as possible is usually within seconds. So it's not as late as okay, it's gonna take 5 minutes before we try everything. We can try so many routes very quickly, and then if we clearly see that okay this stuff is not working, we're gonna ask the humans to get involved and or pay more attention, because if we know that their system is not working, then they should not trust us at that time.
Yeah. I know also that you did some real-world tests. So this is not only, academic research. You actually deployed this on several vessels. Can you tell us more about these tests and what were the results? What were the learning points?
Yeah, of course. So we've done an autonomous ferry in 2018, and we've done inland ships. As well. We're doing tankers now. So I think the initial pilots that we've had and clients, they were more involved into the control of the system and how the decisions are made. So that I think is really what we excel at, is that we can handle hundreds. We haven't tried with thousands yet, but with contacts to be able to still take a decision and go around all these other vessels in a safe manner and achieve our objective, which is basically going to this waypoint or arriving to this port, whatever. And that's how where we're good. I think the things that we're kind of continuously learning now is that how do you explain that decision in a an obvious manner to captains and people on the bridge, so they can understand and start building this trust again in the AI. So you can imagine in 2 years ago when I or a little bit more now when I started blkSAIL, the data was everything's just something scrolling on a terminal, and then all you see is just numbers, and you're trying I'm trying to look at it and observe and understand what it's saying. Now it's it's a chart. It's a nice even font. What's the color of the font? What's these kind of stuff. So it's easily readable, and a captain or anybody on the bridge can have just a quick look at the screen and totally understand what the AI is saying. And I think that's goes with overwhelming less the people and have less cognitive overload.
Goes perfectly in line with this trust building that you mentioned before. And I mean, human-machine interface is without doubt the most critical part in this trust building, because you can process and do insane amount of calculations, but this real information needs to be displayed in non-invasive colors, and they should be not creating fatigue. And I think there is also some research that show that I think humans can perceive in parallel maybe 2 digital information bits, but even 7 analog ones. Analog gauges are way easier to perceive, because you already know the working range and the abnormal range.
You're absolutely right. Yeah, then that's also something that and this is what I was telling you in the beginning, because for example I was really involved in the writing of the early software, so you could definitely see just numbers scrolling, and I know where to look at a number, and I know it's I programmed it, I know where the ranges are, so I know which one is potentially out of range, or something I need to pay attention to. But that's not something that you can give to other people. They're going to be it's confusing. What am I
too much?
This?
It's overload.
Exactly. So now we have these gauges, these stuff that standard, and we're following these design guidelines by the Open Bridge community in Norway that highlights all of these kind of stuff. I think they want to standardize how human machine interfaces are done. So it's not every company does its own stuff, and we really love to collaborate with them and implement their inputs in this.
Yeah. Can you tell us how do you sell this? Does the ship owner buys your solution? Is it rent? Is it used as a service? How does this part of your business model look like?
Yeah, so we right now we are in a kind of a private beta phase where we have some select partners that we're working with on testing this and giving us feedback. So how it's done is through a service, and this is how we see it going forward. So today a ship owner would go and buy the chartering, for example, from Admiralty, the UK Admiralty, or they would go and buy a weather service from someone else, or chartering software from someone else. And we see this as kind of the same approach. We don't want to be involved really in huge capex expenses, unless of course it's a shipbuilder, and then he's asking for recommendations how to make this the ship that's going to run for the next 25 years with autonomy. Then yes, we would have this kind of inputs, and we works with shipbuilding companies in the UK and ship design companies in the UK and shipbuilding companies in South Korea about this. But the main challenge I think here is to be able to get this technology that we truly believe that it's going to be saving lives and making it easier on the seafarers, as little friction as possible. So it's a service subscription. They will get the hardware. The hardware first collects the data, and then when it feels confident that it learned enough of the own ship, it will start at that time giving recommendations to the captain. And of course all of this stuff is also sent to the cloud. So from a ship management perspective, they can see where their ships are, how they're operating, basically a full view, high fidelity view of like their ships and how they operate. Because I think the other thing that I think we're doing that like a little bit less of our competition is doing is that we're not just like looking at the actions of the vessel. We're looking at the actions of like their own ship in the environment. So let's say that there's someone does a hard turn. Like we don't just display this to, for example, the headquarters. Or like, okay, like this guy is doing a hard turn. Why is he doing it? Or is he doing the hard turn? Where if that's something that's happening, we show them the context. Maybe like there is like a near miss. Maybe there's like a vessel that was like I don't know, is broke its anchor or something like this, and this like they needed to operate that way. So that's kind of like the approach that we give, where like it's kind of a full view of everything that's happening around.
Yeah, intelligent information out of just raw data. So what's next for blkSAIL?
Yeah,
what are you guys working towards?
So we are continuously like building, of course, our products, partnering with like the key players here, and we're excited to soon kind of like finalizing our like private beta, and then like opening it to like more public beta. So if folks are interested in trying this, they can like go to our website, www.blkSAIL.ai. blkSAIL spelled blkSAIL. And they can sign up for that for the waitlist, and we will contact them as soon as like a spot opens in our beta program. And yeah, like we're continuously looking for like partners if people like want to try it on smaller vessels, like in closed environments. I think that's like usually easier because like it's less involved. And I think there's going to be like great stuff happening in this space in the future, and people like should keep a lookout.
All right, definitely. So shout out to everybody. Go to blkSAIL.ai, sign up for list, and stay tuned for all the updates coming from Mohamed. So we are at the end. We wanted to thank you for this insightful talk. I wish you all the best to you and company, and hope we can catch up some other time.
Awesome. Thank you, Ryan.
Thanks, man. Cheers.
A good one. Bye.
And that was all for today. Thank you so much for listening, everybody, and stay safe, and see you in the next one. Take care. Oi, oi.